Hi there. Okay, so I thought I would do this video a little bit differently, and I'm going to use the PowerPoint for the notes. So if you can go into your booklet, and I think it's page number 10. We double check here. Page number 10. What is the world made of? Okay, so now we've talked a little about compounds and mixtures and pure substances, and we're just going to make sure we got this all down. Okay, here we go. Remember that everything is made of matter. Okay? Matter can be classified according to the categories shown in the chart below. So matter is either a mixture or a pure substance. If it's a pure substance, it's either made up of elements or compounds. If it's a mixture, it's either heterogeneous, like salad dressing, or homogeneous, meaning all looking the same. Okay? What are pure substances? According to the particle theory of matter, pure substances contain only one type of particle. It cannot be separated out physically. Okay? Pure substances are either elements or compounds. Okay? And elements cannot be broken down further by physical or chemical means, right? After you're at the atom stage of an element, you just have protons, neutrons, and electrons, and that's it. Okay? So for example, hydrogen is an element and it cannot be broken down any further. Compounds are composed of more than one type of element and can be broken down into elements by chemical means. Okay, and the example for this is water, right? Water is a compound and it can be broken down into 2 atoms of hydrogen and 1 atom of oxygen. Okay? So pure substances and mixtures, and mixtures. Sorry, next up, mixtures. Mixtures contain more than one type of element and or compound. Okay? They can be homogeneous solutions, which look the same throughout. They can be heterogeneous solutions, which have a varying composition, like when you shake your salad dressing up and you can see all the bits floating around in it. And they can be separated into pure substances by physical means. Okay, so you can take all the various pieces out yourself. You don't need to do it via chemistry. Okay, so for example, salt water is an example of a homogeneous solution, right? It's a mixture of water and salt, but you can't tell just by looking at it that it is a mixture. You can separate the water and the salt water into water and salt just by boiling it. Okay, you'd evaporate the water and you'd be left with the salt. Trail mix is also an example of a heterogeneous mixture. You can see all the different parts, like the peanuts and the raisins and the M&Ms and the cashews, and you can easily pull out all the different pieces. Okay, so the next piece that I have for you is I want you to try it out yourself. Okay, so let me pull it up here. There you go. So if you turn on to the next page, okay, you have this table in front of you. On the left side, it has a bunch of substances, and then you to determine if it's a pure substance or a mixture and an element or a compound. Okay, so if you choose pure substance, then in the next column, your choices are either an element or a compound. Okay, or if you think it's a mixture, your choices are then homogeneous or heterogeneous. So let's just take 2 random ones. Let's say here, the air inside of a balloon. Okay, this is a mixture. Okay? And because it's filled with our own air that we're blowing into it. And is it heterogeneous or homogeneous? It's a homogeneous solution. Okay, if I take a look at, let's see here, salt, okay, NaCl, this is a pure substance. Okay? And because I chose pure substance, I'm going to now choose whether it's an element or a compound. Well, we know we have two different elements that make it up, so this has to be a compound. Okay. So take a minute and try that out yourself, and then add your answers. Okay, turning the page. Properties of matter. A property is an attribute, quality, or characteristic of something. And properties of matter can be either physical or chemical. Okay? Chemical properties. These are the properties of matter that you can only see when a chemical goes through a chemical change or a reaction. Okay? So until something actually happens, you won't know what the chemical properties are. Physical properties. These are the properties of matter that you can see or measure. And physical properties are things you can sense about a substance with your senses. So what does it smell like? What does it taste? What does it feel? What can you hear? What can you see? And there are two kinds of physical properties. And I'm sure you've heard these words already, and I'm positive we've talked about them too. One is qualitative, right? It has the word quality here at the beginning. So these are the qualities that can be observed but not measured. So they're all your senses. And the other one is quantitative, okay? And these are the quantities that can be measured. So is it 5 inches long? Is it 2 pounds? Did it take 20 seconds? That kind of stuff, okay? So on the next page, I give you a list of all the physical properties and all the chemical properties, okay? And again, you'd only see these when they undergo an actual reaction, okay? And these are the examples of physical properties. There's always lots of physical properties and fewer chemical properties. Okay, so let's try it. I gave you a table on the next page, and let's take a look at it. Okay, so here it has substance name, okay, list for physical properties, and it says 2 chemical properties, but my goodness, if you could come up with one, that would be awesome. Okay? So for example, water. What do you know? Okay, it's clear, it's liquid, its boiling point is 100 degrees. Okay, Celsius. Well, its freezing point is 0 degrees Celsius. I don't know why I'm getting caught up on this and that I can't spell or type as well as I want to. That's okay. So this gives you an idea, right? So here I want you to list the physical properties from the table, and then here list any chemical properties. Now, if I look at this, can water rot? No. Does it react with other chemicals? Yes, true. Is it combustible? No, it doesn't burn, it doesn't rust, and it's not toxic to you. So I guess you could say it can react with alkali metals. Okay, we've seen that with our reactions. So I want you to try the next one. Okay, what are some physical properties of vinegar, and what's a chemical property? What about copper? Okay, what do you think? And a piece of cardboard. Okay, give it a try. And the last one, how can matter be changed? Okay. Okay, substances can go through physical changes and chemical changes. These are different than the properties, okay? So when they go through physical or chemical changes, these are called reactions. Okay, so what's a physical change? A physical change is generally changes in state, okay? So melting to freezing to boiling, okay, or to a gas, solid, liquid to a gas, okay? They can usually be reversed or undone, just like if you have an ice cube, you can melt it and it's water, it's still the same thing. Okay. Change shape or size, it's still the same thing, it's just in a different form. Okay. So for example, a cup of water can be frozen into ice. It looks different, but it's still water, just in a solid form. It is possible to reverse this change simply by melting the ice back into water. Okay. Dissolving occurs when a solution is formed by mixing two substances together, and it is usually considered to be a physical change as well. Okay. Okay. For example, salt water, or NaCl, salt dissolves in water. The salt seems to disappear. However, this doesn't cause the individual sodium and chlorine ions in the water to change. Okay, they're still there. We boil the water, they disappear, and we're left with our salt. Okay, so it's totally reversible. So here's some examples. We have melting ice. We have a hot springs or geyser here, and you can see the steam. Okay, and we have firewood being chopped. It's still wood, it's just in smaller pieces. Okay. Here we're adding food coloring to water, still a physical change. Cutting a pizza up, still a physical change. Okay, now chemical changes. These produce new substances, that is key, and they are difficult or impossible to reverse. And they either absorb energy, so they're endothermic, so like baking a cake, or because it needs the oven in order to turn it into a cake, or they release it, they're exothermic. Okay, they give off energy or light or sound. Okay. Oh, here's my example. You can mix together all the ingredients to make a chocolate cake, add the heat, the oven, and it makes a new substance, the cake. And this change cannot be reversed or undone. Okay, we can't get our baking soda back, we can't get our eggs. It's all gone through a chemical change. And it's made a new product. Okay, there are 5 pieces of evidence that a chemical change has occurred. These test tubes, or these 5 pictures, are the best examples that I have of this. I highlight this, I normally put stars here and circle it, okay? These are the best ones. You should have around 3 of these in order to say that a chemical change has occurred. And the big ones being that a precipitate, which means that a new substance is formed, heat or light is produced, the process is difficult to reverse, and then if you see bubbles, which often means a gas is formed, or a color change has happened. Okay, a color change by itself doesn't mean that a chemical change has happened, but as soon as you see a new substance being made, and you know the process is difficult to reverse, most likely you have a chemical change. Okay? So let's take a look. What do you think? Chemical change or physical change? What do you think? Chemical change or a physical change? Right on. They're both chemical changes. We can't get them back to the original products that they were. Okay? Here are some more. Physical change, chopping wood, burn the wood, chemical change. Okay? We have a nail that has rusted. This is a chemical change. And an egg that has fried is also a chemical change. Okay, question number 1. Fireworks going off is an example of a chemical change. Right on. Okay, it's made new products. It's hard to reduce. Lights have been emitted. Sound has been emitted. Heat has been emitted. Okay, and there's a color change. The feeling of a soft blanket on your skin is a physical property. How do you know? Well, you can easily remove the blanket and that soft feeling goes away. Okay? It's reversible. And the last one, I mixed together some powder I found in a lab with an acid. The solution starts fizzing and bubbling and eventually spills over the sides of the beaker. This is an example of what kind of a change. How do you know? Okay. Well, based on what we're saying here, I would say this is a physical change. All we were told is that there was fizzing and bubbling. We have no idea what actually caused this, if it was a chemical reaction, if there was a precipitate, etc. Right? So all we know is that one of these things has happened, that fizzing and bubbling has occurred. Okay. Okay. Next page are a few questions, A to J. I want you to try them out. Okay. And let's check your answers and see what you get. Here we go. Milk spoils in the fridge, chemical or physical? Chocolate goes soft in the hot sun, chemical or physical? Oh, sorry. Milk spoils in the fridge, chemical or physical? I'm gonna do this. Just like this. Okay. This is a chemical change. Okay. Chocolate goes soft in the hot sun. Okay. Physical change. We can get it back. Okay. Platinum wire turns red when held in a flame. Physical change. Leaves change from green to red in the fall. Chemical change. The metal on a bike frame turns from silver to reddish brown. Okay, that's rust. That's also a chemical change. Food is digested when it's eaten. Chemical change. Definitely does not look the same when it comes out of your body. Okay. Sawdust forms from wood being cut with a saw. Physical change. Brown liquid forms when coffee grounds are put into hot water. Okay, so this is dissolving into water. Physical change. Ice breaks into smaller pieces. Also physical change. And carbon dioxide is dissolved in carbonated drinks. Okay, and here we have a chemical change. Right on. Nice job. Super excited. Way to go.